Hi guys, let me apologize in advance for all the background noise that's going on. I'm sitting at the airport, so I hope you can hear me okay. This is an introduction to lesson 3.2, where we're wanting to be able to identify from the graph of a relation whether or not that graph is a function. We talked in class the other day about a function being when every x is paired with only one y value. So we'll look at how we can see that on a graph. And then we also want to be able to obtain all sorts of information from the graph of a function and calculate all sorts of values. So here's a table that displays the year and the price of gasoline per gallon. And that information, year is the x and price is the y, that information is displayed in this graph. So you can see, for instance, that in the year 1985, the average price of gasoline per gallon was $2.50. In the year 2014, the average price per gallon of gasoline was closer to $3.50. So you can see how the price per gallon has changed and fluctuated over the years. Now, if you want to determine if this graph of a relation, and it shows the relation between year and price per gallon, if you want to determine if this relation is a function, you can run what's called the vertical line test. On a vertical line, every point on it has the same x coordinate. So this point here on that vertical line has the same x coordinate as this point here, and as every other point. So on a vertical line, there is not a one-to-one correspondence between x and y. Because, for instance, this point here might represent 1991 with a price per gallon equal to $3. This point here is also 1991-ish, but the price per gallon is $2.50. So you can see the year 1991 is paired with more than one y value, which will be true on any vertical line. So when you pass a vertical line through a graph, what you're verifying is that it passes through that graph in only one place. And if it only meets that vertical line in one place, then we say that it passes the vertical line test. There's a one-to-one correspondence between x and y. There's only one x on that line and one corresponding y value. So to say the vertical line test, it says that a set of points in the coordinate plane is the graph of a function if and only if every vertical line intersects the graph in at most one point. Because if it meets it in more than one point, then there's not a one-to-one correspondence between x and y. So when we look at these graphs in A, it doesn't matter where I pass a vertical line, it meets that blue parabola in only one place at any time. And therefore it passes the vertical line test and is a function. We can say the same thing about B. Any of these vertical lines meet that blue graph in only one place. And so we can say, yes, that is the graph of a function. But in C, I can see if I pass, for instance, this vertical line through that graph, it has 2 points of intersection. So those x coordinates are both about 4, but the y coordinate on top is about 2, and the y coordinate on bottom might be about -1.5. So you can see that 4 is paired with 2 different y values, and therefore this is not a function. It does not pass the vertical line test. The same can be said of this graph in D. These vertical lines are meeting in more than one place at a time, and therefore that relation is not a function. Well, now we want to be able to obtain information from the graph of a function. And this is an example of the kinds of questions that we might ask you to answer with regards to the graph of a function. We might ask you to find the value of y when x is 0. We were practicing this with an equation in class the other day. So we might say, plug 0 into this function and tell me what the y value is. Or plug 3 pi over 2 into this function and tell me what the y value is, and so on. We want to be able to find the domain, which is the possible x values, and the range, which are the possible y values when we look at a graph. We want to be able to find the intercepts, both those that cross the x-axis and those that are points of intersection with the y-axis. We want to be able to determine how many times does the line y equals 2 intersect the graph. Now, it won't always be y equals 2, but we're going to want to look at a graph, or be able to look at a graph, and determine how many points of intersection are there between that graph and a particular line. Here's another example of finding values of x that correspond to a particular value of y. And so let's just take a look at a graph and try to answer these questions. First, we want to find f of 0, f of 3 pi over 2, and f of 3 pi. So f of 0, that's where x is 0. Well, here is where x is 0. If we go up to the blue graph, we see right here that the corresponding y value is 4. So we can say that f of 0 is equal to 4. Or we asked for f of 3 pi over 2. Well, 3 pi over 2 is right here, and I can see that the corresponding y value there is 0. So we can say that f of 3 pi over 2 is equal to 0, and so on. But we also want to be able to identify the domain and the range. And again, in class the other day, we talked about the fact that the domain gives the possible x values. Well, I can see that this graph goes as far left as the y-axis and as far right as this point right here, at that vertical line. Well, you notice at the x-axis, of course, our x value is 0. And you notice at the far right there, our x value is 7 pi over 2. So we could describe the domain as being all real numbers, or all values of x, that are between and including 0 to 7 pi over 2. Now, your MyLabs Plus is going to use set notation to describe that, interval notation to describe that. So first, a couple reminders about interval notation. When an inequality has an equal sign with it, as both of these do, we will be using brackets. Okay? If there is not an equal sign, rather it's just like a less than, then we will use parentheses. Well, it does include an x of 0. We see that right here in this point. And it does include an x of 7 pi over 2. We see that right here in this point. And that's why we're going to be using brackets. Now, in this case, our interval isn't too hard to describe. It goes as low as 0 to as high as 7 pi over 2. So this is interval notation to show the interval in which the domain lies. Now, when we look at a graph and want to determine the range we know is about the high and low. It's all about the y values. Well, I can see the highest y values are right here, and the lowest y values are right here. So our y values have to be between -4 and 4, including -4 and 4, because they do go as low as -4, and they do go as high as +4. So we would describe our range, if we were using just inequalities, we would say that our range is all values of y between and including -4 to +4. But if we're using our other notation, it does include -4 and it does include +4, so we'll use brackets, and then we put the minimum on the left and the maximum on the right. So that is our range of this function. We were also asked to determine how many points of intersection there are with this function and with the line at y equals 2. So a line at y equals 2 would be this line here, where every value on it has a y coordinate equal to 2. And I can see that it intersects the function here, 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 and here. So we would say that this function has 4 points of intersection with the line y equals 2. That's not so hard. We also asked you to identify the intercepts. Well, we've got one y-intercept right here at +4, and typically MyLabs Plus wants you to give it as coordinates, so that would be the point 0, 4. But we see that it has 1, 2, 3, 4 x-intercepts. And so where are those x-intercepts? Well, if this is at pi/2 and this is 0, this point here is smack dab in the middle of 0 and pi/2. So halfway between 0 and pi/2 would be the midpoint, and we've learned how to calculate midpoint. You add the two coordinates. In this case, we're interested in the x coordinates because of the fact that we're looking for x-intercepts, and you divide by 2. Well, 0 plus pi/2 is pi/2. When you divide that by 2, that's the same as multiplying by the reciprocal of 2. So that would be pi/2 times 1/2. That means that x-intercept is at pi/4. So one x-intercept is at pi/4, but again, they like us to give those as coordinates, so pi/4, 0. The next intercept here, I wish I had more space, is right in between pi/2 and 3 pi/2. So if we find the midpoint there, pi/2 plus 3 pi/2, and then divide that answer by 2, this is 1 pi/2. So 1 pi/2 plus 3 pi/2 is 4 pi/2, which is 2 pi. And so we get, so 4 pi/2 is equal to 2 pi, so our numerator here is 2 pi, but that has to be divided by 2 to get the midpoint, so we have another x-intercept at pi. And so on for these remaining 2 x-intercepts. So there are 4 x-intercepts on this graph. We were also asked to determine where f of x is equal to -4. And so we're not giving you the value of x, but rather we're giving you the value of f of x. So we're actually, f of x is just f of x is just saying y is equal to -4. Well, I can see that y is equal to -4 here, and I can see that y is equal to -4 here. So the values of x, where f of x is -4, are pi and 3 pi. And finally, we were asked to identify where f of x is greater than 0. So again, f of x is just y. Where is y greater than 0? Well, y is 0 here on the x-axis. So we can see that it's greater than 0 between here and here, because the blue graph is above the x-axis there. We can also see that it's greater than 0 between here and here, because again, the blue graph is above. And we can also see that it's greater than 0 between here and here. So if we look at that first interval, it's greater than 0 from 0 to 2 pi, or pi over 2, excuse me. It's also greater than 0 in between here. That's from 3 pi over 2 to 5 pi over 2. And then it's also greater than 0 from 7 pi over 2 to, from 7 pi over 2 to 4 pi. Now this is where MyLabs Plus asks you to enter it using the appropriate notation. So let me demonstrate here. If you look here at question G, which is the one we're addressing here, we said that it is above 0 from 0 to pi over 2, also from 3 pi over 2 to 5 pi over 2, and also from 7 pi over 2 to 4 pi. So notice the notation. This actually, the first interval, notice, when it gets back to pi over 2, it's at 0, and that's why it's not above the y-axis anymore, but rather it's on the y-axis, and therefore they've used a parenthesis here to show that it's not above the y-axis at pi over 2, but at everything up to pi over 2. Same thing here. It wasn't above the x-axis at 3 pi over 2 or 5 pi over 2, which is why they're using parentheses to show that it doesn't include those values. And the same with the last interval. And then this symbol is union. Union is just set notation for the word or. So you would say that this function has f of x greater than 0 from 0 to pi over 2, or from 3 pi over 2 to 5 pi over 2, or from 7 pi over 2 to 4 pi.